is 3.
Okay, good. So let me introduce ourselves. My name is Shadab Hasan. I'm a process engineer and working in EPCL. Shadar is also process engineer working in EPCL, but at different plants like PVC1, PVC2, PVC3 experience he has. And Bernard is from Uganda. He's the CEO of his company Apple Vision. So quickly we will ask you a few questions one by one. Okay, when I ask you question, that it means that I asked you both at one time and you both need to reply on the same question one by one. So you both have studied petroleum refinery in the last semester, right?
Yes.
Yes.
So tell me the types of column you studied. Like, for example, azeotropic distillation, simple distillation, and
We studied ASTM and true boiling point columns.
okay.
True boiling point contains plates, while ASTM does not contain plates.
No, I am asking about the types of distillation. Like I've given you an example, like extractive distillation is a type of distillation, azeotropic, and how many types are left? Do you know about Fenske equation?
Yes.
Where it is used?
Fenske equation. It is used for minimum reflux.
Minimum number of theoretical plates.
Minimum reflux.
Can we
Underwood is
calculate
used for minimum theoretical plates.
Can we calculate the feed Q line, energy line of the distillation column with Fenske equation?
Yes, we can calculate with few correlation we have studied in last semester. Chemical plant design. We calculated by using Fenske equation minimum number of plates.
What is Murphy efficiency? And ideal number of stages. What is the difference between Murphy efficiency and ideal efficiency? Ideal number of stages.
Ideal number of stages are the minimum number of stages for the minimum duty required, and Murphy.
Atis, who drives the column? Condenser or reboiler?
I guess reboiler, because it used to add up the energy and converts into vapors.
So do you consider reboiler as a theoretical plate during the calculations?
Yeah, exactly, because reboiler is also considered as a theoretical plate, because at that time vapors and liquid are in equilibrium as present in the liquid.
So for example, if you have a column with a reboiler duty of 4.6 megawatt and you want to calculate the condenser duty, how will you calculate it?
Basically, we can calculate on the base of action which it performs, that how it converts into vapors, the liquid, and
you will
that's
apply the
how-
energy balance, right?
yeah, exactly. We can do the energy
And
balance.
how the energy balance you will apply?
Basically, we can apply the energy balance that on the base of accumulation, that how much the change occurs with respect to time. That is the main thing.
Will you not consider the feed energy?
Exactly, we can consider the feed energy as well, because of course, again, if the feed coming inside having some kind of heat energy itself, so we can consider it as well.
Muzaffar, what's the difference between boil-up ratio and reflex ratio?
Boil-up ratio is the amount of vapor generated as compared to liquid which flows down in boiler, whereas reflux ratio is the amount of liquid coming into the column as compared to distillate going out.
Like for example, if I increase the reflux, then what will happen with the top temperature? It will increase or
Top
decrease?
temperature will decrease because reflux is liquid. It will absorb latent heat.
What will be the effect on the pressure? if I increase the reflux?
Pressure will also increase because the amount of vapor will increase due to vaporization.
And what's the equation for reflux?
McCabe-Thiele
Yes, McCabe.
equation.
What's the
for
other
reflux.
method? Sorel Lewis.
Yes, Sorel-Lewis.
Suppose we
Reflux.
have a steam, suppose we have a steam revolver and we want to calculate the steam flow rate. How will we do that?
It depends upon the vapors that is required from the boiler. According to that, if the vapors are required in low quantity, then steam will also be required in low quantity because low heat transfer is required, and the opposite will happen for high quantities of vapor.
Atis, if we increase the number of theoretical stages, the efficiency of the column will increase or decrease?
If we increase the number of plates, so efficiency of column will increases.
And what about the cost?
Again, we can always we prefer the two things, our product and our cost. But if the product is productive, so we go with the product, and we cannot prefer at that time the cost. It depends on the efficiency of our product, then how we obtain that.
How will we find the optimum number of plates?
Basically, we will having different methods like McCabe method, Lewis Sorel method. We can find out plates through that as well. But those methods will be considered as the biggest method or a descriptive method. So we move towards the fancy question to find out the number of plates or minimum number of plates.
How many types of trays are there?
How many types of trays? You're just asking about the trays we are using inside the distillation column, right?
Yes.
I cannot get it.
What are the different tray designs that are available? He's asking that tray designs. There are different configurations, huh?
Yeah, exactly. We will having different configuration. You're asking about then
Muzaffar, do you know it?
There are bubble cap trays
Okay.
and perforated trays, orifice, and
Sieve trays, valve trays, pro valve trays, mini valve trays, flexi valve trays, profrac trays. Which
Who
has
would offer the
larger
most pressure drop? Yeah.
Yeah.
For example, if we compare sieve trays with bubble cap trays, who would offer which tray design would offer the larger pressure drop, the higher pressure drop?
Bubble cap tray will have larger pressure drop because the vapor will have to travel longer distance in bubble cap trays.
Can we install the packing inside the column other than the trays?
जी sir, आवाज नहीं आई.
Can we install the packing inside the column other than the trays?
It depends upon the feed. There are some conditions. Packing cannot be installed if the diameter of tower is too big or if the overall column is big, and if there are some conditions in which packing is favorable and some conditions in which plate is favorable. Pressure drop is higher in packing as compared to plates.
Pressure drop is higher.
Yes.
And if we talk about structured packing and random packing, अगर इन दोनों में अगर compare करना चाहें, what would be the difference in pressure drop among both of them, both of the different types of packing?
Structured packing will have lower pressure drop as compared to random packing.
Packing normally has a minimum pressure drop as compared to trays. So in the columns where we have problems or issues related to the pressure drops, we remove the trays and install the packing.
So what would be that? Sorry, आप complete करना चाहिए.
Yeah, what's the design L/D ratio for the columns?
.3, I guess.
Do you know about vapor loading?
Vapor loading.
Downcomers.
Yes, downcomers are the part where liquid flows down to the next plate.
How
Is it
will we
mandatory?
identify? Yeah, Shazad, please ask.
Yeah, just two questions, quick. One, AK, if I use if I use a column with the packing inside it, what would they, and the other one with like trays in it, right? Sieve trays. So what would be the difference in diameters of both the columns? Which column would have the
That
higher diameter?
higher diameter will be of the plate one.
All right. Atis agreed?
Yeah, exactly. We will be having higher diameter in the plates one.
So would this be the only criteria that I would consider while going for the installation of the equipment?
Basically, I guess that we would prefer the plate one because it will gives us higher efficiency product. That's why.
And is it mandatory to have the downcomers installed in any column, in any stripping column, in like every stripping column, or we can have the column without any downcomers and just the C phrase on it? Is it mandatory to have the downcomers?
Yeah, exactly, because the downcomers is all about that the liquid flows down. So if we have that, so again the liquid on the condensate side will be moved easily downwards. So it's necessary for the distillation because it doesn't cause any kind of problem in the distillation column.
What's the
And if I'm
definition of
talking,
distillation? Muzaffar, what's the
Yes.
definition of distillation?
Distillation is basically separation of two or different compounds in a mixture on the basis of different boiling point or relative volatility.
What is relative volatility?
Relative volatility is the amount of vapor generated as compared if we compare two compounds in a mixture, the amount of vapor generated is volatility. The higher the vapor, the greater the volatility.
What is the normal value of RV?
tell me what's the basic difference between distillation and fractional distillation? Is there any difference on it, or the two terms are used interchangeably?
I think in fractional distillation, we also have side streams as compared to normal distillation where only top product is obtained.
How many relief valves are recommended on the column top? And what should be its type? Atis.
Yes, I guess that we will be having a relief valve at the top side, basically, and to remove the bubbles, and we will having the relief valve at the downward side as well, near the boiler. I guess.
Why
Is
the
there
relief
any
valves are
difference?
installed on the columns? Why the relief valves are installed on the columns?
Basically, I guess that basically relief valves is used to basically remove the pressure or the air bubbles. Uh, um,
What kind of bubbles?
uh, Basically, with the liquid which converts into vapor, some liquid is with the vapors is moved downwards, so that will be removed really well. That's why we will have it.
Muzaffar, do you know what I'm asking?
Yes, safety valves are applied because if for some example feed flow rate decreases, due to that vapor will increase, and if vapor increases and there is no safety valve, then there is chance of explosion happening. So that is why we install safety valves.
So okay, good. So we are introduced safety valves for emergency scenarios, and it's the last line of defense, right?
Yes, yes.
So how many types of relief valves are there? Conventional हो गया, conventional pilot operated
Butterfly
butterfly valves.
Or globe valve.
So what is the difference between pump back and pump around? Have you guys heard of that term?
Pump
Is there any
around
difference
is
between
when we pump from lower tray to upper tray any liquid, that is called pump around.
pump back?
Pump back नहीं पता.
And why is it done? Is it done? Why this operation of pump around is done?
It is done because sometimes it happens when distillation column is big that the reflex cannot reach properly to the bottom plates. So to increase the liquid coming from top, a pump around is used to lower the duty.
Does it have anything to do with the concentration or the purity?
Yes, it also increases the purity.
Is there any difference between the term concentration and purity? If I'm talking about like refinery operations.
Concentration is simply moles per unit volume, whereas purity defines as that how pure the substance is. Is there any impurities that like which are chemically bonded to the substance?
Okay, let's recap. Okay from my side.
Bernard, are you there?
Yes, I'm around.
Yes. We have completed our firefighting with the questions. Now it's up to you to ask questions from these two guys.
Muzaffar and Muhammad, how are you?
We are fine, thank you.
We are fine. Thank you.
Yes, my name is Bernard, and I'm a practicing chemical engineer. I'm the founder and the managing director of Apple Vision Limited, which is a consulting and engineering company in Uganda. I've been in the industry for the past 7 years, and I'm really very grateful to interact with you today. I hope we shall enjoy the discussion. When we go to the university, we go to get knowledge and skills, right?
Yes.
Yes.
So I would like Muzaffar, kindly tell us what a chemical engineer should know in terms of skills.
Skills like he should know about the operational side of plant, like instrumentations, and other than that he should stay calm in pressure, because situation may come that quick decision making is needed. So calm under pressure is a good skill to have. Other than that, leadership skills are also required, because at some chemical engineering is like a field where it is the major in any industry. Like if petroleum industry, chemical is major engineering. So at a time comes where you have to be in a leadership role. So this skill is also very important.
Well, that's good. Muhammad, in the industry, we have manufacturing plants, chemical plants, I would call. There is I have a friend who works in a chemical plant, and they manufacture methanol. Methanol is an aldehyde, it's a carbonyl compound. And the process involves the conversion of methanol directly. So I would like to know from you, is this a unit operation or a unit process? And why is it so?
Okay, so you have asked about that your friend has introduced about is producing methanol, and is it a unit operation or unit process, right?
Yes.
Okay, so basically, if you're just producing the methanol directly, so it's all about the unit process. But if it coming up with different procedures, with different processes, so we will take it as unit operation, because operation includes different processes and different stages, and after that we will obtain methanol.
Muzaffar, what can you add on?
Yes, I think that if any chemical changes to the raw material is occurring, then it is a process. If just the physical changes are occurring, like crystallization, for example, it is unit operation.
Just like you've been talking about the distillation, what happens inside the distillation column? Is it a unit operation or a unit process?
I think it's an operation because separation is happening. No chemical reaction is occurring. And basically, bubbles travel up in the accumulated liquid and they transfer heat and mass and carry upwards with them the similar compounds that is present in that liquid, which means the liquid that is of high volatility. So that is how separation happens in distillation.
That's true. Now, this goes to Muhammad. In chemical plant design, what is the first step that you undertake before you go any further?
Okay, so basically, when we are going to design a plant, so first of all, we should know that what we are producing and what we want. First of all, we are going to analyze our the whole process, and then afterwards, analyzing that, we will move towards the process flow diagram, so as to instruct the diagram that how we will start from raw material towards the product, the final product, and that's how first of all we have to analyze the process completely.
Before we do any design of the process of the equipment, what is the first thing that we need to know?
Okay, so before designing, first of all, we should know that the process, after analyzing the process, we should know that what our process include, how many designing plants are included in our complete operation and complete process. So before designing, we should know every stage, what are the requirements of every stage. So that's
Muzaffar, have you done
Yes.
a chemical? Have you done any chemical engineering design project?
We are currently doing, but we have not proceeded to designing stage.
Why? Why haven't you gone up the designing stage?
Because first part was our project is basically simulation based. It is solid waste gasification. It is basically waste to energy conversion. So first we recognize that what process will be used, what kind of reactors from Spin Plus will be used for the process. Then after that we search the net for Karachi based study, because our project is Karachi based. We've collected data. Now we are at the stage where we will do designing of individual equipments.
Yes, I want to understand from both of you. Okay.
okay.
Why do we design processes?
First
Why?
of all, yes. First of all, by designing, we can, as compared to that, we do experimental things, and it may cost us money and stuff like that. Designing is basically we have our objectives. We know what we are trying to produce. By designing, we can calculate what amount of energy is required, what amount of raw material is required, just on paper, without doing any experimental work, without any cost.
Okay, there is one thing I wanted to hear, but I think it is not coming out. And that thing is, we design to solve a problem. Is that true?
Yes.
We design processes, we design equipment to solve a problem, an existing problem. Is that true?
Yeah, exactly.
Yes.
It's true.
Yes, that's what I wanted to hear, but I think it was, I don't know, missing out. We design to solve an existing problem, and in the first place is to know if the problem actually exists. Now, I want us to go through the stages of chemical plant design. Which one's the first stage? After you've identified now there is a problem, what's the first stage?
First stage is like we are using if a set of equation, we must know our assumptions properly. Like if there is, we can either create a model where the model is very simple, but it is not very accurate. And on the other hand, we can also do that the model is very accurate, but it is not able to solve manually, or it requires computer solving, supercomputer solving. So first we have to think about the assumptions. After that, we have to draw up process flow diagram. We have to know that what process is happening, by what process we are going to solve the problem.
Muhammad, what do you have to say about that?
Yeah, as I prefer my project, final project, that's all about the experimental base. So first of all, we need to do is about the research work. After getting research, much research, we are going to analyze our project completely. Then afterwards, we need to know about the availabilities for our processes. That what is the raw material, what is the basic raw material, is it available in the market or not? And then after analyzing that, we are going to select our process. And after the process selection, we are going to make a process flow diagram, complete process flow diagram. And then after that, we will further proceed up. About the experimental project.
Do you know what we call feasibility analysis?
Can you please repeat it once again?
Feasibility analysis.
Okay, feasibility analysis, right?
At what stage do we do that?
I guess that an experimental feasibility analysis, according to me, is that we are going to analyze that what are the feasible ways to produce manufacture our product. So we will do after the process selection that what are the raw materials present in our process, is it available or not? So there we will go with the feasibility analysis.
Muzaffar.
Yes, feasibility analysis is generally done near the end. After the process is selected, we know what equipments we are using. Then after that, we do feasibility analysis generally.
What do we do during feasibility analysis? Maybe let's first understand what do we do during feasibility analysis. What do we do in a feasibility analysis?
Like we check that whether, like for example, our operation is being conducted at 1500 degrees centigrade. For example, we have modeled it. Everything is working. Answers are coming, but it is physically not practical to operate at such high temperature. Such thing is also for very low temperature, like we are doing liquefaction of something. We have done modeling and everything is working out, but the product is liquefying at minus 250 degrees centigrade. So it is not feasible practically. So that is what we do.
So that is from a technical perspective. You look at the operational feasibility. How about from the economic perspective?
Yes, we also have to take the net effect of the project, that how much we are consuming and how much valuable is our product, and whether the maintenance cost are not too high, and the process is feasible or not.
I'm sure you've done course units in chemical engineering economics. I don't want us to go there. What's the difference between preliminary design and detailed design?
Can you repeat that?
What's the difference between a preliminary design and a detailed design?
Can I answer?
Yes, please.
Oh, basically, preliminary design is what about that before analyzing the complete process, whatever we basically design on the paper on a very small basis, that is a preliminary design which will be done before process. But after that, after getting complete research and analyzing our whole process, whatever we design is all about the detailed design of the complete process, starting till the end.
Yeah, that's right. Have you heard about PID?
Yes.
PID?
Yes.
How about PFD?
Yes.
Yes.
How about P and ID?
Yes.
What's the difference between these two? Can you see this? Can you see this?
Yes, yes.
PID?
PNID also tells us about the instrumentation and what instruments are used, like temperature, what kinds of instruments are used to control temperature, pressure, and while PID only tells us what kind of valves, like wells, are connected to what line and stuff like that.
Are you sure? Muhammad, what's the difference between these two?
I guess
in chemical, in chemical engineering.
Okay, I guess PNID is a piping and instrumentation diagram, and PID is a controller which we use for controlling purpose for our process.
Exactly. PID, those are controller. It's a controller, proportional, integral, and derivative.
Okay.
And then P and ID is piping and instrumentation diagram. That's so great. I really appreciate it. And I don't want to spend much of the time. What I can confirm is that you are knowledgeable, you are skilled, and you have the confidence, you know how to communicate. But the other thing that I would like to say is you need to be very sure, because in the industry, you must be sure it is either you know or you don't know. Otherwise, you're going to cause disastrous situations in the industry. What you're not sure, it's better you say, I'm not sure about this. You be open, yeah. Okay. What you know, you say, I know. That's the only comment I can give you, but you are all knowledgeable and skilled. Thank you. Over to you, Hassan.
Okay, Muzaffar and Atis, hope you have enjoyed this drive of mock interview. If you have any questions with us, then you can ask us.
यार उर्दू में पूछ लूं?
पूछो यार, बिल्कुल, go ahead.
पूछो.
मैं ये पूछना था, जनरली क्या इसी तरह जैसे अगर एंग्रो पावर में अप्लाई कर रहे हैं हम, तो क्या इसी तरह डिस्टिलेशन से रिलेटेड सवाल ही होते हैं?
नहीं,
डिस्टिलेशन असल में सर ने पढ़ाई इस तरह से, तो मतलब इतनी पक्की नहीं है.
असल में डिपेंड्स ऑन द इंटरव्यूअर मूड. मतलब जो इंटरव्यूअर है वो मतलब आपसे क्या पूछना चाहता है. जैसे शाजर ने कुछ कैंडिडेट से पंप्स के बारे में पूछा था, मैंने डिस्टिलेशंस के बारे में पूछा. तो ये अगर आपके पास एपीआईज थे ना, एपीआईज जो होती हैं एमसीक्यूज बेस्ड, वो आप जो मेन इक्विपमेंट्स हैं जिनमें पंप्स हैं, हीट एक्सचेंजर्स, इसके अलावा डिस्टिलेशन कॉलम्स, मेजर इक्विपमेंट्स जो हैं, इनके बारे में आप पढ़ लो. आपके इंटरव्यूज टेक्निकल पार्ट तो निकल जाता है इससे. बाकी शाजर के पास अगर कोई एडवाइस है तो वो आपसे शेयर कर लें.
यार एक बिल्कुल शाजिर भाई ने आपको बताया ना, गाइड किया, एंड बेनार्ड ने आपको गाइड किया. कॉर्नरस्टोन प्रिंसिपल्स यही सब है, क्योंकि इन लोगों का एक्सपीरियंस बहुत ज्यादा है. बट मेरी सजेशन सिर्फ एक चीज में है कि यार जस्ट बी कॉन्फिडेंट. अगर जिसका जवाब ना आ रहा हो, यू नो, ऑलवेज एक्सक्यूज इट, बट डोंट से कि मतलब ऑलवेज लाइक यू कैन से इट लाइक दिस वे कि यार मतलब I'll look up into it ना, and if possible I'll get back to you on this. That is also a very polite way of responding to the other person. And the other चीज ये है कि instrument section is also very important. Process control section is also very important. Just at least have a, you know, उसका एक आउटलुक, सरफेस नॉलेज होनी चाहिए आपके पास एटलीस्ट, कि चल क्या रहा है exactly, ठीक है? But it's very important as far as process engineering is concerned. And lastly, चीज ये थी कि जैसे FERT के उन्होंने APIs को कहा, FERT की APIs हैं, I guess. FERT ने बनाए हुए APIs. You guys can go through them. It will give you an idea about it. बाकी keep your learning antennas on, ठीक है? You know, just जब भी हुआ करे, you know, just be open to the information flow, ठीक है? And that's about it, yeah. That's about it.
ऐसे शाजर अगर ओवरऑल देखा जाए तो जो स्टूडेंट्स हमें मिले हैं, मतलब जो इंटरव्यूज देने के लिए आए थे यहाँ पे, उनमें कॉन्फिडेंस का मसला था ज़्यादा ना, मतलब टेक्निकली उनको आंसर्स मालूम तो थे लेकिन they were hesitate to share with the interviewer.
बिल्कुल बिल्कुल एंड एक चीज मैं पहले मिस कर गया, वो थी कि if an interviewer throws you a question that what is your favorite subject, that is a very plus point, that can be a plus point for you, because तब आपके पास choice होती है for you to, you know, respond him in a way that you want him. Okay, for example, if your plus point is, you know, chemical reaction engineering, if your plus point is fluid dynamics, then you can, you know, answer in that. Fluid dynamics is one of my, you know, go-to subjects, and he'll ask you questions accordingly. So जो Muzaffar साहब ने पहले question किया था, that is an answer to that, but it depends upon what he asks you first.
So
communication is very important. Yeah.
Shazan and Bernard, who is the star of today's interviews?
Yeah, for me it was AIChE.
And Bernard, what about you?
AIChE.
Votes for her.
Okay, so from my side, too, AIChE performed very well today with clear explanation and lion's attitude with consistency and confidence. So overall, this activity was really good, and I would like to thank AIChE and everyone made part of it, and especially Bernard, who has given us this important time. So thank you very much, Bernard, Shazar. So let's finish these interviews and it's Saftari time now.
Thank you.
Thank you.
Muzaffar, thank you, and Atis, and all the very best for your, you know, for your future endeavors. Thank you, Bernard. Thank you for sparing time. Thank you, Shazir. Thank you, Shazir, for, you know, inviting us to this episode. Thank you, everyone.
Thank you for inviting me, Hassan. I hope next time you will still invite me.
Yeah, sure.
Me too. Me too.
Yeah,
Yeah.
of course.
Thank you.
Bye-bye, Bernard
Bye-bye.
and Shazir.
Bye.